All right, good morning, everybody, and thank you for joining our Not Your Average Fungicide webinar. Today, we got about an hour and a half of deep dive information into everything fungicides, and we're going to hear from three different presenters here today. First off, we'll lead it off with Dr. Matt Montgomery. Matt is going to talk about some modes of action, and Matt is our agronomy education lead here at Beck. So hailing from that central Illinois area, he's going to bring us some insights on the modes of actions of fungicides. Our second presenter will be Mike Blaine. Mike is a field agronomist and technical training lead here at Beck's Hybrids, coming to us from Minnesota today with some insights on decision-making and resistant management, wise decisions to make when using fungicides. And finally, we'll wrap up with Clayton Stufflebeam. So Clayton Stufflebeam is a PFR agronomist here at Beck's down in that Lewiston area of Illinois. Clayton does all our on-farm research trials, so bringing us some good information about application techniques and all the studies and findings that he's brought us over the years through practical farm research. So everybody here on the call today is muted. As we go through, if you have questions, feel free to use the chat box down in the lower right corner, and that's where I'll put my cell phone number too. So if you'd rather shoot me a text with a question on it, we'll make sure to monitor those and get them answered as we go through the presentation. So we'll stop frequently, ask the questions, and continue to move on. So feel free to ask any questions you have. The more questions, the better. This is designed for you to gather all the information and as we come into fungicide season here and help make some profitable recommendations. So I will kick it over to Matt Montgomery to start us off.
All right, I'm going to get ready to share my screen here. And just to check here real quick, John, to make sure that everybody on that end is seeing the full screen.
It looks good, Matt.
Fantastic. Okay, everybody, like John said, we're going to go through a few different things, kind of three different sections to what we're going to cover today. The first section is this, and then we're going to move on to Mike talking a little bit about how you use those tools, kind of strategy, philosophy, and then Clayton's going to talk about some of those PFR findings. And so the real core of what I'm presenting today is helping us understand how these tools actually work. And this can get a little bit heady, but I want you to hang in there with me because I think we're going to get you some word pictures that help you understand very clearly how each one of these tools, these families that we tend to use when it comes to foliar fungicide applications, how they actually do the thing that they do. This is going to be kind of my outline for today. We're going to talk about potential targets. Then we're going to talk about a group of fungicides called the triazoles, and I'm going to give you the techno speak on how those work. But then we're going to throw out a word picture or a mental picture that I think helps you understand that better. Then we're going to talk about strobilurins. Then we're going to talk about what we call SDHIs. And again, we're going to do the techno speak for how those work, but we're going to very quickly move over from that to kind of a mental picture that I think helps you grasp the idea just a little bit better. Before we begin, I think this is always really important to put on the table. And whenever I've talked to people about modes of action, be it herbicides or fungicides, I've tried to stress this point. You know, cells are really delicate pieces of hardware. And really, with our pesticide tools, the tools that we have in our toolbox, be they herbicides or fungicides, what we tend to do is take advantage of that delicate nature of the cell. We remove one little tiny thing, and that cascades into the cell not being able to survive. And that really is how a lot of our toolbox works. I want to talk just a little bit about the potential targets. I'm calling this the short list. It's because this is the short list. The list would be actually much longer if you went through all the different options that we have when it comes to fungicides. I'm going to cut it down to this short list today, and I'm going to talk about three main targets that we tend to talk about in row crop ag. And these are the three main targets inside the cell. Sometimes we'll hit something called the RNA. Sometimes we'll hit something called the cell membrane. Sometimes we'll hit the mitochondria. That RNA topic, we're not going to really hit for today. That'll be a webinar that we decide to do sometime in the future, probably. Those are tools that tend to be like your seed treatments, like the old ones, like Allegiance and Apron, are the ones that kind of hit that. What we're going to focus on today are kind of these two targets. We're going to talk about stuff that hits the cell membrane. We're going to talk about stuff that hits the mitochondria. Again, don't get lost in that terminology. We're going to kind of get this down to some terms that we all can understand. We're going to begin with this group of material that's called the triazoles. Sometimes they belong to a larger group that's cited as the DMIs. And if you looked at the techno speak about how this stuff actually works, you'd see that it damages the cell membrane. I don't want you to get lost in that. What I want you to remember is a mental picture, and that's this. I want you to think about triazoles as fungicides that take the mortar out of the wall. And I'll explain more about what I mean by that in a second, but that's what I want you to grab a hold of. Fungicides that take the mortar out of the wall. This is kind of a list of the different products that kind of fit under that family. You'll notice that most of these end in ZOLE, so it gets really easy to figure out which materials belong to the triazole family. And you'll notice some common names there. So you'll notice things like Xyway, right, or Tilt. These products tend to be really good curative products. That doesn't mean they heal the plant, but it means they can burn out pre-existing pathogen in the plant. They come with a medium resistance risk. That's going to be important for us to consider here in a bit. Mike Blaine is going to talk just a little bit more about some of the attention that we need to pay to resistance management. This is medium risk. There are some products we're going to talk about in a bit that are kind of high risk. And that's important to remember because some of those high risk products tend to be the generic single mode of action products, and we should go into using those with our eyes wide open that we want to be good stewards because we want to keep this toolbox really, really, really full. So with that, let's really talk about these triazoles, the things like Tilt and Xyway, and let's really kind of bore down on how this actually does its business. So if you looked at the cell membrane, kind of that shell that helps form the cell, and you looked at it from a distance, it looks, yeah, pretty simple. But if you zoom in on it, you find it's actually much more complicated. You can tell there are little pieces to it. And if we zoomed on it even closer, even further, you would see little blocks that make up that cell membrane, some things that seem to make up the majority of it. And there are these little fat things that are kind of nestled here and there within it. We're going to look a little bit closer at those real quick. I'm going to give them some names. I don't want you to get lost and blown away by the names. I want you to keep that mental picture that I talked about earlier about mortar in your mind. So the stuff that makes up the majority of a cell membrane, the majority of that shell that actually forms the cell, is what we call lipid. Okay, that makes up the majority of it. But tucked away here and there within that cell membrane are these fat little things called sterols. And if you were to look at the techno speak that goes even just a little bit deeper on triazoles, you'd see that they say that they are sterol inhibitors. Again, easy to get lost in that. This is the picture that has always helped me, and this is what I want you to grab a hold of. So think of a cell membrane, that shell that forms the cell, as being kind of like a brick wall. And the bricks in that wall, the stuff that makes up the majority of that wall, are the lipids. But you can't just have a wall that's only bricks. You got to have stuff in between, right, to tie it together, to give it some resilience. That stuff, the mortar between those bricks, are what we call sterols. So think about a cell membrane as looking like a brick wall in some ways, with lipids being the bricks and sterols, the mortar, being there as well. And when we apply triazole fungicides, we actually target those little fat things. We kind of take them out, And we wind up with a cell membrane that, at least for today, we're going to say kind of looks like this. But maybe a better mental picture is for us to think of that cell membrane looking a little bit more like this. This is what triazoles do. So think about triazole fungicides taking the mortar out of that little wall that we call the cell membrane, and you're left with nothing but the bricks. Imagine this as your home, and you're trying to build a foundation on this, and you can imagine there are some problems. Number one, that base can shift, right? That foundation can buckle if it's just bricks. It doesn't hold up very well to pressure. The other thing is, if this is the foundation or maybe even the wall of your basement, it's not going to do a very good job at keeping outside liquid like water in the soil out of the house, right? If you have only a brick foundation, no mortar in it, it's going to allow stuff to seep in. And that's really how triazoles work. They don't keep stuff out of the cell very well. They cause that cell to be kind of just the bricks. They take the mortar out and stuff seeps in. And eventually what happens is that those cells swell up, swell up, swell up, swell up, swell up, and they burst. And that really is how triazole fungicides work. So things like tilt, again, things like Xyway, any of your multi-mode of action, multi-active ingredient foliar fungicides have a triazole in them, and that the material in that category works this way. It pulls the mortar out of the wall gets leaky, the wall bursts very easily. That's the mental picture I want you to grab a hold of when we think about these products. Let's move on to another group of products now. Let's talk about strobilurins and SDHIs. Now, the techno speak on this is that we would say these are fungicides that stop respiration, that process that lets the cell harvest energy to keep the cell alive. I want you to set that aside for a moment, and I want you to grab a hold of this mental picture. I want you to think about strobies and SDHI fungicides as being fungicides that dry up the dam. So we said triazoles pull mortar out of the wall and that cell membrane gets leaky. I want you to think about strobies and SDHIs as stuff that dries up the dam, and I'm going to explain that just a little bit more here. Again, 3 targets. We said we're not going to talk about RNA today. Again, allegiance, apron, seed treatments. We've already talked about triazoles. What we're focusing on here when we talk about the strobilurin family of fungicides or the SDHI family of fungicides are the mitochondria, where we get the energy, where we harvest the energy to keep that cell alive. And again, I want you to set that aside for a moment, and I want you to kind of begin to think of these mitochondria as acting like a hydroelectric dam. Um, Again, this actually is applying to how these materials work. Imagine a hydroelectric dam. You know how a hydroelectric dam works. You have some key components, right? You have a dam, you have some structure that lets water pile up on one side and not so much on the other. You have a reservoir where the water actually piles up. And as the water flows through the dam, it spins a turbine, and that generates the electricity needed for us to do the stuff we want to do. Okay. Again, this actually does apply really close to this topic that we're going to talk about here in a second. So imagine a hydroelectric dam. Imagine those key components. Start to get those fixed in your head. And now I want you to pause and I want you to think about a actual real life hydroelectric dam, a specific dam, the Hoover Dam out west, right? And it forms Lake Mead that actually feeds water to a whole bunch of people out in the western United States and generates a lot of electricity for people out in the western United States. A real hydroelectric dam. Now, just a few years ago, the Hoover Dam had a problem. And some of you may remember this as you're watching today. We had the drought of 2022 out there, and the water level in Lake Mead began to drop. Actually, you can see on the satellite photos there on the right that it literally began to dry up. We began to see historically low water levels in Lake Mead. And that led to kind of some of this that you see right here. The blue line on the left-hand side of the screen is again mapping out the water level of Lake Mead, and you can see there in 2022 it hit historic lows. And that led to a series of headlines that some of you may remember in the media where they said, boy, if this keeps up, literally, we're going to have a hard time generating electricity with the dam, with the Hoover Dam. That headline down there at the bottom, Hoover Dam might not be able to generate electricity. It might have to shut down. And that really brings up a key weak point, a pinch point in hydroelectric dams. The key weakness is when that reservoir gets too low, that dam stops its work. It's not able to generate the energy that we need. Why did I bring all this up? Because folks, actually, mitochondria that are targeted by SDHIs and strobilurine fungicides, mitochondria are actually just a bunch of little, even though they're the powerhouse of the cell, they're actually just a bunch of little hydroelectric dams. Literally, you can peel these things open and they have tiny little, what we're going to call hydroelectric dams inside. But the dams are just a little bit different. You and I think about a hydroelectric dam as having rivers that feed into and fill up the reservoir. The dams we're going to talk about are a different kind that I want you to imagine. Instead of having rivers or tributaries or streams filling up that reservoir, these have pumps. So there's one more important piece to this little dam that I'm having you imagine right now. We do have the dam still. We do have the turbine that spins and generates energy or harvests energy. We do have the reservoir, but instead of streams and tributaries, we have a pump that pumps the water in. If you open a mitochondria, you'll see that there are these little wavy things inside of it. And if you're like me, you look at those and you go, huh, it kind of looks a little bit like the Hoover Dam. And that's because that's exactly what they are. There are literally tiny little dams inside the mitochondria, and they have the structures we just talked about. So if we would zoom in on those little purple ribbons and we would look at a cross section of those little purple ribbons, we would see something that kind of looks like this. These are the structures that are involved in what we call respiration. Again, I don't want you to think about that term. I want you to think about this term of it acting like a hydroelectric dam. You have a membrane, and that's kind of like the membrane that forms the cell, right? Except it's inside the mitochondria. Guess what? That membrane is basically just a dam. It's a structure that allows stuff to pile up on one side and have not so much on the other. We also have a reservoir where we're going to pile stuff up. It's not going to be water. It's going to be charged particles, but it's the same idea. It's going to pile stuff up on one side of the dam. And believe it or not, we actually have a turbine, a generator, and it really does spin. And we call this little generator ATP synthase. And when that thing spins around, it's generating the energy, it's harvesting the energy that cell needs to stay alive. If it doesn't spin around, that cell doesn't have the energy it needs to stay alive and it dies. And remember, I said there was another key component to this different type of dam, this different type of hydroelectric dam. I said this one had pumps. All those blue things on the screen are pumps. And for today, we're going to keep it simple. We're going to call it pump 1, pump 2, pump 3, and pump 4. They have some fancier names, but we're going to call it that for today. And you can start out with different stuff, and that kind of determines which one of these pumps is used. There's some fancy stuff called NADH, FADH2. I don't want you to remember that. What I want you to remember are the slides that are coming up because they show how this really does. These little blue things really are pumps. Okay, so we're going to talk about this stuff called NADH. And so when these pumps are engaged, they pull a hydrogen. They use an electron to pull a hydrogen into the pump, and they spit that hydrogen on the other side. Stop right there. They're doing exactly what we just talked about. You've just pumped something behind the dam. That little electron moves on to the next little pump. it pulls in another hydrogen. So it actually goes from pump 1, not to pump 2, but pump 1 to pump 3. Don't worry about that. Just keep your eye on what's happening here. It pulls in that little hydrogen, spits it on the other side of the pump. Again, just like a hydroelectric dam, it's feeding that reservoir and building that reservoir up. We've simplified this just a little bit today, but you get the idea. Again, we're pulling in another hydrogen, we're spitting it on the other side of the dam, and you get exactly what I'm talking about. These are the little tributaries. Those pumps are the tributaries that are filling up the reservoir. And eventually, we wind up with a situation inside the mitochondria where we have a whole bunch of stuff piled up on one side, not a lot of stuff on another, and this generator sitting in between. Again, it literally is like a hydroelectric dam. And as hydrogen flows back through and spins that little turbine, it generates ATP, it generates the energy needed for the thing to stay alive. Again, the big picture I want you to grab a hold of is inside the cells of your body, my body, of plant cells, of fungi. There are these little structures called mitochondria. They have little dams in them. Stuff piles up on one side. It flows through. When it does that, that generates the energy that's needed for that cell to stay alive. Now, strobilurin and fungicides, again, we're talking about techno speak here, are fungicides that hit, I guess we could say, respiration from both sides. Remember, I mentioned that stuff we could start with, that NADH or FADH2. That's the techno speak. Here's what I want you to remember for today. Think of that hydroelectric dam that's inside the cell of that fungi, of that pathogen, allowing it to have the energy to stay alive. And what strobies are doing is they're knocking out what we're going to call the central pump. And when we knock out the central pump, you can guess what's going to happen. The reservoir is going to run dry, and that's bad news for that cell having the energy that it needs. Strobilurins are an example of our high-risk category. And so there are a lot of perfectly great generics out there, but we want to be careful with how we apply those. We don't want to do that just kind of off the cuff. We want to put some thought into it, kind of like what Mike's going to talk about here in a bit, because these are highly resistance prone. We don't want to overuse them so that we wind up with pathogens that don't kind of get controlled by this category of fungicides. We want to be good stewards. You're familiar with the terms here. There's products like Quadris, Headline. Again, the actives all end in strobin, so it's real easy to keep track of these. And what they're doing is, again, they're knocking out pumps. But they aren't knocking out that very first one on the left. They aren't knocking out that last one on the right. They're knocking out the one right in the middle. But you can imagine what happens if you knock out a pump, if you knock out one of the tributaries that feed that reservoir. What's going to happen inside that mitochondria? You're going to have Lake Mead in 2022. The water level, the level of stuff inside that mitochondria is going to drop to historic lows. And the headline inside that cell, when we use a strobilurin, is going to be that we can't fill up the dam and get the thing to work. And it's no longer going to generate the energy needed to stay alive. So again, we don't have stuff piled up on one side. The generator's there, the turbine is there, but it's not doing anything. Again, we could use some different stuff. It starts out with a different pump, but it all goes through that middle pump. And again, strobilurins knock out that middle pump. It's the same deal again. We don't have stuff piled up on one side of the dam. We don't have the ability to harvest the energy we need for that thing to stay alive. The fungus dies. SDHIs are really similar. They're doing something very similar. It's just they're hitting a different pump. We might call them fungicides that hit respiration from one side if we wanted to do techno speak. What I want you to remember is that they're hitting the non-central pump. They're hitting a non-central pump, but they're still hitting a pump. They're still knocking out one of the tributaries that fill up that little reservoir inside the cell that helps the cell harvest energy. And if we do that, that reservoir is going to run dry and it's not going to be able to harvest the energy we need. The resistance risk here is medium to high. So not quite high like strobilurins, but there's still some risk there, and we want to be good stewards of that. Any of the 3 mode of action products that are sitting in the marketplace, at least 99% of the time, those have, we talked about earlier, triazole. They have a strobe that we just talked about earlier, and they have an SDHI in them as well. And what that SDHI is doing is it's knocking out pump number 2. But again, the big picture I want you to get is by not having that pump, I don't fill up the reservoir. The turbine doesn't spin for the cell to have the energy it needs to stay alive. Inside that fungus, inside its mitochondria, it's Lake Mead 2022 running dry. And the energy level goes down, and that fungus eventually dies. That's how these materials work. Triazoles, really, really good at being curative, at trying to knock out a pre-existing pathogen. Think about strobies and SDHIs as kind of products that are a little bit more prone to protection, to trying to keep the fungus from ever getting in to begin with. One other thing I should mention here before I do our review on mode of action, I should be mentioning that when we talk about fungicides, a big general rule to keep in mind is think about these products as having very limited mobility. They may spread out a little, but 9 times out of 10, we're talking about very limited movement past the point of contact. And so a good general rule has been, kind of the general principle has been, you want good coverage. One of the things I'm going to mention here is that I think we, from some of the work that Clayton has done, are finding some exceptions to that rule. And Clayton's going to talk about that in a little bit about some theories for why we're able to get some stuff maybe that works when it doesn't get quite the coverage that you might expect. I'm going to just mention that because I do want you to keep in mind that coverage is really important. We want to make sure we have the right, kind of higher gallon sizes, small droplet sizes. That's the general principle. Kind of keep these products in mind as not lasting forever, maybe 10, 14 days, and then they kind of whittle away because the environment breaks them down. That's the general rule. I'm going to let some of the other folks on the call today talk about specifics. But to wrap up, I want to do this mode of action review. Again, triazoles in any multi-mode of action product, or at least 98% of the multi-mode of action foliar products we have on the marketplace, they're knocking the mortar out of the brick wall that is the cell membrane, causing that cell to rupture. That's how they work. Curative products. QOIs and strobilurins and SDHIs, think of those as being things that cause the little dams inside those fungal cells to dry up. You can't get the energy needed to keep the cell alive. The cell dies. And these are really good at kind of keeping the fungus from getting in to begin with. And with that, I'm going to stop sharing my slide deck here. And I'm going to make sure I pass it off to Mike Blaine.
As you do that, I had 2 questions come in on the text line.
Yes, sir.
The first one is exploding cell walls or knocking out the pumps. How long does this take? Like, is it as soon as it hits
Yeah.
the leaf, or?
No, so there's going to be a period of time, right, that it takes for that kind of damage to appear. Now, I think sometimes with the triazoles, in the matter of several days, you can see sometimes even on plants a little bit of cellular damage, of burn sometimes to the leaf that can appear. The strobilurin thing, it's going to take a little bit of time to kind of whittle away at that energy level, right? They're going to have some energy reserves, and those kind of wear down with time. So think about maybe a few days on the triazoles, probably going to have several days before we see the really big stuff happen with the strobies kind of stopping stuff, if that makes sense.
Question number 2 was, with the SDHIs and the strobilurins both attacking the mitochondria, Is there such thing as cross resistance to those modes of action?
It's probably something that we need to be conscious of. So I'm not aware of cross resistance having been detected yet between SDHIs and strobies. But I do think something to keep in mind is they're both knocking out respiration, right? And we talked about strobies being highly resistance prone. I do think it speaks to when we use SDHIs, we want to be kind of in our mind trying to be as good as stewards with those SDHIs as we are strobies. If strobies are kind of resistance prone, you saw that moderate to high resistance ranking on SDHIs. This shouldn't be stuff that we just use and figure it's a magic elixir that has no potential ripple effects associated with it. We want to make sure we're good stewards with them and using them very wisely and using them in combination with other active ingredients.
Another one in from the chat panel here. Will adding a high quality adjuvant help with coverage to increase mobility and longevity within the plant?
Let's push pause on that one because I want to make sure Clayton talks about some of his stuff here in a bit, which will kind of tap into a little bit of that.
Final one in the chat box here is, which group provides the most plant health benefit in the absence of disease?
Yeah. So I think there has been some thought that the strobies, that something happens there with use of strobilurins that seems to change how the plant functions. It is interesting that that respiration thing is at work. And there, I think there has been a little bit of thought that the strobies might be kind of some of the more plant health benefit, at least in my mind. That's kind of where I've settled.
That wraps up our questions for you right now, Matt.
Appreciate it.
So,
Thank you.
Mike, if you want to kick it off with your portion, and to everybody on the call, these have been fantastic questions. I know the guys presenting here today love answering the questions and getting the chance to use their minds and give recommendations. So keep them coming, please. Mike?
Very good. Coming through loud and clear. Very good. So again, my appreciate for all those that have joined today. I'm not going to probably take it to the science level that Dr. Matt has, but I think the building blocks when we were working together, the concept came up, and I'll make sure I acknowledge Matt for that opportunity to take place. So the one thing I'll follow up with Matt's comment on respiration. If you caught anything, when we look at the strobilurins and the SDHIs, they are knocking down the respiration of the fungi. And so if that's competing, then the plant, therefore, if you want to say, when we talk about some products, talk about helping plant respiration, they're together is really what we're trying to achieve, eliminating competing respiration of a fungal pathogen. So with it, so fungicides, most of us are familiar with them, and I think that the big part when I worked on this a number of years ago before gray hair is that they are part of our fish and food production. And when I thought through it, when I started wearing the crop protection hat, it really occurred to me that in some places fungicide application was taking place without thought to what we're really trying to manage. And so when we think about the resistance that Matt laid out for the different groups that we use, the risks that are associated with them, that's ultimately the key concept as we go through. So again, why it matters is that when I think about weeds, insects, and bacteria, where we have varying to very high levels of resistance, it really comes down to if we continue to use the same products without regard to the crop we're managing or potentially the pest we're managing, it doesn't lead to a good situation. So as we work through this and we give mind the various resources that I'll work through, is that we're really not saying not to use fungicides, but we want to continue to preserve the effectiveness so that we, as growers advisors, farmers, if you will, that we maintain control of the decision of how and when we use fungicides. So there's a lot of information. The what is really understanding and managing. Matt gave a huge boost of the understanding. I know when his example on the triazoles, the mortar and the brick, that took my brain to another level as far as how we're applying them. And Clayton will hit into that, when and how we apply if we have disease present. And, that's the key concept of the different modes of action, or frac groups, as we'll talk about. So why it does matter, because we do have today primarily strobilurine resistant diseases, frog eye, leaf spot, soybeans, cercospora, and other broadleaf crops, including sugar beets, septoria, brown spot, and some of our other dicotyledon crops. And so to me, it matters every crop every year, and it matters on every field and every farm how the decision is made. And that part about how we again, our resources. And for the most part, in our PFR studies, we're using multi-mode fungicides somewhere during the testing season. So here we come to the big decision factor, decision model when we look at the disease triangle. And so, do we have a host that's susceptible? Is the pathogen present or anticipated to be present? And is the environment supportive for that disease? This isn't a disease workshop, but the thing we have to keep in mind is that every disease has a different supportive environment. And we can work backwards all the way to our seed treatments, whether it's Pythium, Fusarium, Phytophthora, Rhizoc, Tonia, the big four for seed treatments. Each one does have its desired or preferential environment. So again, if we don't have a plant that's susceptible to a disease, or in other words to put it, is it's very tolerant, then we can look at the disease triangle and say, well, I have a host, but it's not very susceptible. And so then, that leads us into the next conversation. Just a quick review, and you'll see many of our slides, my slides I have for you, I've titled 101, 201, and it's kind of the building block when we think about fungicide use and management. Hope it'll make sense as we work through it. Again, Matt covered how they work. And then my component is, and Matt listed a number of the key individual products, but it's to really understand what's in the product you're using. I know there was a couple products that came out one time, be it from BSF, in this case Priaxor, and the combination of the SDHI and the triazole just didn't carry the weight that it was intended to be, and it really came back to probably not, didn't have that strobilurine, plant health, plant respiration function strong enough, and then the triazole load, and it was not sufficient if disease was present. So, and as you go through, can you name another fungicide with the active ingredients used? Just think about the products you are using and what's in there. And I forgot, I heard when I started out, for those that haven't heard me present, I always try to, at the beginning, say that I don't argue success, but I will try to do my best to ask the right questions to find out why something is being done. Again, this is so important, how it works. When we think about our herbicides today, we probably didn't give them due diligence in the conversation and how they're working and how we're applying them. And that's led to some less than desirable situations. Call out the fungicide classification by FRAC. It's an industry group, and it's really, FRAC just stands for the Fungicide Resistant Action Committee. And so you'll see that in various materials, including on fungicide labels, university extension publications, and we also reference when we need to in our PFR materials what group or mode of action or FRAC code that a fungicide has. It can get confusing, but there's fairly uniform consistency now with all fungicides, especially that are labeled as far as which frac group and their mode of action. So when we get to that, going back to the disease triangle, we look at our fungicides, are not our host. And I just took a snapshot from the product and program guide from 2024, 25. And we look at, in that product guide, we do characterize a number of primary foliar diseases in corn. In this case, gray leaf spot, northern corn leaf blight, and tar spot. And again, Goss's bacterial wilt is a bacterial pathogens. We won't hit that. And so when I look across at to the right here, I can look at this hybrid, and it's a 6 for tar spot, and if 9's best, 1's least desirable, we can look at that. So and really where that comes is that when I think about it is whether it's the proactive management, knowing your products, whether it's corn or soybeans, corn in this case, which products do I need to focus on first or be most attentive to from a host to a given pathogen. Here's another look at it. Our product profile sheets, both in our Beck's product guide and also online, that can be easily accessed to take a little bit deeper look at the diseases that pathogen has tolerance for, or a higher level of resistance, semantics on the word. And then the other thing that comes into play is its adaptability and population flexibility. Many growers, having worked in the corn for silage market, where planted populations are extremely high, we saw some of the immediate effects of plant health management of the strobilans back 20 years ago, because we did have greater stress on the plant. And once the disease started, because of the canopy, moisture and temperature was very evident. And the last thing I'll call out is staging. And that really comes down to it. It's more or less a phenological, it's observed trait, but it becomes very important as we think through the host. If that hybrid's a 9, and again, 9 in our system is best, is this the hybrid that we need to target a fungicide on? When we think about fungicides, we have to keep in mind that host and growth stage. Just obviously very little fungicides going on V1 or V2 corn, or probably even V3 soybeans, but there's a number of resources. Make sure you use them. As far as growth stage, if you're not familiar with it and confident in it, I think that's the most important thing. Currently, there's a lot of soybeans in the indeterminate that we're coming into R1, which becomes a critical timing for growers managing white mold or sclerotinia stem rot. And knowing where you're at is critical to the success of those products. Too early, too late, you can miss the mark completely. The other thing is, again, the resources we have for growth stage. Not perfect. Your eyes and boots in the ground are always going to be the best. But looking ahead, if you're not using Farm Server as a base reference, I strongly encourage you to do so at all levels, because it really is, it's for most growers, it's invaluable knowing their planting date. And as we'll see, the local collection of environmental data that actually drives crop growth. And again, for many of us, we've seen this very similar slide when we're looking at growth stage timing in corn. At one time, there was a fairly strong differentiation for between BT when we have the tassel out versus R1 when the silk's out. And you'll see today, whether it's on your own farm or field, the majority of our products, we're either neutral, where we're seeing pollen shed and silk emergence, or very close, we have silks emerging and no ripe anthers yet. And then again, other hybrids where we probably see, pollination before we're seeing silks. So the pathogen, going to that disease triangle, tar spot. Tar spot for most geographies has expanded widely. I think we're going into our 10th growing season since it was first identified in north central Illinois and southeast Wisconsin. But, this is just an image of it if it's out there. And what we can think today across the majority of the Corn Belt, including the western and northern Corn Belt, we have tar spot inoculum in place. And so today, when I visit with growers, tar spot is on the radar. Several operations where last November they bought pallets of fungicide to be proactively and be ready. Here was the part, it was the other part of the farm server, the lower half of the screen, and again, going to that disease triangle. Do we have supportive environment? This I pulled as of yesterday, and looking ahead to our temperatures, and I'll give you a reference coming up on one of our disease reference that lists, for the most part, the preferred growing environment, including temperature and leaf wetness and so forth. But we can look at where we're at. So if I looked ahead, there's a very high chance of rain coming, which may not be conducive, or I should say, could be conducive to the disease, but obviously less conducive to applications. And then that's where Clayton's part on drones comes into play. How can that tool, regardless of the other things that we do or don't know about it, how can that be a very valuable tool if we are managing field conditions that aren't agreeable to ground application? Thinking about the crop we're managing, I got a white mold or management example coming up, and it's really about that conflict. When we look at this soybean growth for indeterminate soybeans, that confluence of the pathogen, the host, and environment. For the most part, we know once we have flower sloughing, we can have, and the timing of the white mold ascospores being released, comes into this play, and then it comes back all the way through our flowering. And so the most important flowers are the first flowers on the plant, typically on our indeterminate soybeans, and it's that node protection as we go throughout the flowering period. When we come to that general overall plant health with a combination product, now we're trying to really stage it. Why are we trying to stage it? Because it's this R3, because we're on the front end of seed filling, but we're in the heart of flowering. We have pod development, and yet at the same time we have this vegetative growth. So, keep that in mind versus on our grass crops. 8 out of 10 fields, the most important timing is going into that pollination period where we're done with vegetative growth. We're not going to get any taller, darker, or greener, as I tend to use the words. And so we now have to manage anything disease that's there on our corn crop, as well as take advantage of the plant respiration benefits that have been seen with the strobilans and to a lesser extent the SDHIs. I beat this up because I think it's very important. We have this, again, is probably for some of you out of maturity range, but when I think about probably our number one, if not number two product, 5077, it's not an Achilles heel, but we do know that its tar spot tolerance is low relative to some other products that sit around it. And so when I think about that product, if I'm going to be scouting and focusing my fungicide management, it may be 5077. On the flip side, I come to 5647, which was part of my earlier example. Again, these sheets are available for each state or sales area. I look at it, we talked about it, stay green. Our primary pathogens that we're dealing with on an annual basis are northern corn leaf blight and tar spot. And I look at that and say, yes, I have a gorgeous field of 5647. It's my home run hybrid, but yet that field of 5077 probably may need my eyes and attention before 5647. So our hybrids, they do have differing susceptibility ratings for all diseases. And as we know, there are currently no hybrids that are resistant to tar spot. I can go back again when I was cutting my teeth on the front end of various races of northern corn leaf blight, and where there was the race shift, and you learn pretty quickly what genetic tolerance or resistance is. And so that is, and if I don't hit it multiple times, that becomes our most valuable tool, not unlike when we look at soybeans for growers that have seen white mold before. I would anticipate in their selection process, selecting a soybean variety that does have a higher rating is still our first cultural line of defense, and then we move down the line. So, and then the other thing is that, as I mentioned, maybe 5077, even though its tar spot rating is average and its response is going to be higher, we don't want to ever put ourselves in the position of only selecting a hybrid because of a specific characteristic in general, different than we talked maybe in soybeans or white mold or the other matrix, decision matrix, when we look at, is that hybrid going corn on corn, what's been the history of the disease and so forth. I bring this back up because, again, that timing of the fungicide, Xyway has shown in our own work, PFR work, and seen a number of examples on Growers Farm, it's very effective, the most effective molecule I've seen in the last 35 years at controlling fusarium infection in the crown, which leads to crown rot and premature death. And the other thing is on white mold. Once you see any instances of white mold in your field, it's too late to treat it. So that's the other thing to keep in mind, is that even though you may have the pathogen, an application of any of our PFR proven fungicides, once crown rot is started, is not necessarily going to, it's not going to cure it or prevent it. It may help in the plant health and further infection or further movement of the infection later on in the plant or later on the growing season. So trying to put it all together, we look at using the tools we have available, when our planting date was, where the corn's at today, and using this tool to project. So if you're hiring a drone operator, a fixed wing or helicopter guy, it's not perfect, and if the weather in the north has bounced from too many days, 50 to 90, and so the crop growth doesn't follow a uniform or linear curve. But keep in mind to use the tools, keep track of the weather, and here now that we start moving from the majority of the corn, everybody on the call is probably looking at V10, a lot of V10 plus corn, and then that tar spot being our pathogen of discussion. So then we come to the fungicide. We circle back and we think about the fungicide I'm using. This is an example for approach fungicide and the crop. So there's a number on the label. We will talk about the diseases that are controlled. Control is not an empirical term. Control can be from, just like a rating can be, from something to something better. So to keep that in mind, and obviously it all comes down to what Clayton's going to talk about. We can take a crop of susceptible host. We can use an effective or selective effective fungicide, but if we don't manage it correctly, our benefit will be limited. So I'll probably try to, I can check my time, work through these next few slides. A number of resources out there. I talked about the Fungicide Resistant Action Committee, the FRAC. They have resources that are available that talk about our products. A number of the products here listed, this is coming from the Crop Protection Network, which is a summary publication put together by land-grant universities, extension and so forth, talking about the primary modes of action at the top here, and then the diseases. Again, there's a lot of fungicides. The fungicide label should give you the indication what it controls or helps manage. And then this really comes from the years of data and both disease ratings, research trials, and so forth. And so, I just had this conversation yesterday with a grower looking at being proactive with tar spot, and in our part of the world, southern rust. Some growers that came in much earlier than we've typically seen it, and the value of a fungicide for both proactive and preventative perspectives was very beneficial. So, and as you'll know, most of the PFR proven products are on this list. They're multi-mode of actions. And as well, then the good thing to see is the ratings for, in this case, when we talk specifically about tar spot. Here's that summary of the industry looking at the products. This is a good resource. The one thing they do and make it a poster, you've probably seen it at a crop protection retailer. But again, the better, more aware we are of the products we're using, building back to what Matt's point on the different resistant risks are there. I don't think any of us want to be in the position 5 years from now if we have a tar spot every field and every farm, and our options to manage or control it are down to just one or two products. That's not good from a resource management, and sometimes the market takes advantage of it in a way that doesn't benefit our ROI. This Crop Protection Network on an annual basis for corn, soybeans, wheat, small grains. Then there's also a companion one for soybeans and soybean seed treatment. And you look at that one and you'll see that the portfolio that Beck's is using for Escalate is pretty solid for all the known early season soybean pathogens that we see. I hit this before, making sure you know what disease you have. If you have Fusarium and crown rot this year, then these are on the left, these two plants showing the value of Xyway, and then you can see here where the Fusarium or crown rot has established. So even post-mortem, anytime through the growing season, knowing what diseases you have in your field and you're trying to manage is very important for the decisions you make the next year. I can skip through that one. So this again is a resource that's on the Beck's website. It was updated here a year and a half ago. It talks about the primary pathogens that we work with in the Corn Belt. What this North inoculum source is, the lesions, or the symptomology, when to scout, and then also gives you a thumbnail of the conditions conducive to infection, as well as some management strategies. Here's the current tar spot as of Tuesday of this week. Whether it's fortunate or not or enough, I filled in the majority of the counties in this area. I got a couple of bad samples that they didn't post for either Traverse or Wilcombe County, but as you can see, tar spot from going back in 2016, were first identified in this area, has moved quite well across the Corn Belt. And this will be my lead into Clayton's talk. And again, on the putting it all together, use the resources. I really feel that this summary of our PFR proven ones, the summary of the application, the modes of action, and who's manufacturing is probably a one-page invaluable resource to have on your phone. So with that, John, I will stop there, and if there's any questions, comments, or complaints, I'll see if I can address them.
Thanks, Mike. Got a question on the text line, and it's a loaded question, so here it comes. All right.
All right.
With the farm economy the way it is, I can buy the components of some of these pre-mixed fungicides cheaper than I can buy the premix. Any harm in buying the components or active ingredients and blending them together as opposed to buying the branded premix?
Well, it's when you put your crop protection hat on or the retailer hat, it's the support. So if that product is bad, your product doesn't work, then typically with generics, in very few cases do you have that support. But by all means, no. I mean, that's where those resources, whether it's the FRAC group, their ratings for the products individually, or looking at the crop protection networks. There, that's really one of the impetuses when we started talking about this, is that there is some high quality generics. Not all generics are the same. Keep in mind that whether it's Syngenta or Bayer or BSF has probably spent 7 to 10 years on the formulation end and the specific surfactant or adjuvant that works with the molecules that they're using. So no, there isn't. But the watch outs and the pitfalls are those that I mentioned. So just make sure whatever generic you're using is effective on the disease that you're trying to manage. I think that's really what it comes down to.
Another question that brings the farm economy and economics and ROI into play here is, in my area, we have been hit with many recommendations for 2 passes of fungicide in the reproductive stages. This could easily total $70 an acre. Do you have a recommendation on 2-pass systems? And if I were to try and cut costs, would you run a generic up front or for the later pass? Again, loaded questions and opinions here. So yeah, fire away.
There's a half a dozen questions I'd ask first. Obviously, which crop? It was the corn or soybeans, and what diseases are we trying to manage? I think Clayton will have it, and I have it in some supportive slides. But we're looking at PFR. Can we, on corn specifically, can we go with a generic azoxystrobin or Quadris up front and extend or make our anthesis or BTR1 application stronger? And really what you're seeing is that there's nominal yield benefits, but the ROI, even using a generic, gets chased down very low, if not to zero. So again, depending upon the disease, I mean, again, before gray hair, I can think back 20, 25 years ago where we had a boost of corn on corn, we had anthracnose, and today the genetics that have the opportunity to position and sell, our anthracnose ratings today are 2 to 3 times higher than what I recall back then. And so it was, that's genetic breeding and products and product selection. So for tar spot, boy, I don't know. I'm not the expert. I don't want to be the expert. I acknowledge that. I'll let somebody else be the expert on tar spot after I move on. But I think all the data coming out of the industry and extension, specifically for that disease, we're best to be scouting and make sure that we've identified that pathogen before we get into the 1, 2, 3 shot, because we might shoot all of our bullets up front. And when we know, I think it was 2020, the impact of tar spot across at least the central corn belt was greatest at R2 to R3. And so that would be a long answer. But by all means, you got my number. I'd be more than willing to talk further.
Very good, Mike. Thank you for the presentation. I just want to reiterate some of the points you made. Utilizing that disease triangle, identifying the diseases that are present and know what you're going after with the correct active ingredients are things that will ensure that we keep resistance at bay with some of these fungicide classes. These are valuable tools we have, and if we start building resistance similar to our herbicide programs and we run out of tools, it could be pretty detrimental for the crop. So good stewardship of those by selecting multiple modes of action, actually identifying the diseases that are present, and then thinking about the future outlook for weather and the presence of disease are all things to keep top of mind, because just like the herbicides, bringing new modes of action and new active ingredients to the marketplace right now is a difficult and long-term project. So thank you, Mike. We will turn it over now to Clayton Stuffelbeam, our PFR agronomist, to hear some of his findings and recommendations for applications and the studies he's doing in the field. Clayton, take it away.
Thanks, John. Everybody hear me all right? Give me a thumbs up, John, if you can hear me.
We hear you good, and your screen is sharing now and
coming. Okay, we're good.
And looking good. So everything's, you're a go.
Okay, all right. Like John said, I'm Clayton Stuffelbeam here, building off the base of what we're going to talk about today in my portion. I'm going to start with the profitable spray pass guide that we have available. That's kind of the basis of what I'm going to cover today. To get that guide, you can scan the QR code that I have here on the screen, or you can just simply go to our website. If you want a hard, an actual guide in your hands, reach out to your local Beck's representative, whether that's Seed Advisor, ATL, or somebody from our agronomy team. A lot of good tidbits in there, including PFR, practical farm research data, and opinions from our agronomy team as well. Before I get moving, I do want to talk about what is PFR proven. So for a product or a practice to receive that stamp of PFR proven, that product or practice must have been tested at least 3 years, at least tested at 3 locations. It must increase yield for those 3 years of that testing session. And then most importantly, must increase return on investment average for those 3 years. To get that stamp of approval, that product has got to be profitable and pay for itself, and then a little bit above that, above break even. Those are the products or practices that if you were looking to try something new on your farm, where I would start. Coming into fungicide products themselves, I've kind of boxed up the top 3 that we've tested. Like Matt said earlier, a lot of our products are premium products that we've tested. Moravis Neo, Veltima, and Trivapro there on top. Veltima, I'm just going to kind of go from left to right. So our return on investment column is the green column. Veltima, $27, almost $30 an acre return on investment. Application costs are not built into this math. Application costs vary from geography to geography and from different application methods, whether that being a ground machine, drone, or helicopter and airplane. So we keep those out. So kind of figure those in as we go through all these slides. Application charges are not built in. The next column to the right would be our return on investment win percentage. So with Veltima, 85% of the time, it is profitable, made us money, okay? Yield advantage would be 10.7 bushel per acre. And then yield win percentage, it wins, adds yield 100% of the time. But it isn't always profitable, but 85% of the time is a very good win percentage. Next up would be the application rate and timing that we tested that, or the timing that it got tested to become PFR proven, and then modes of action, so strobilurin and trizol, and then the company that provides those products. That is the base of these trials. So the products themselves, and then we'll go forward here and talk about other things we can do with our fungicide applications to maybe add some more effectiveness or profitability to that spray pass. So this is an adjuvant trial. It is a 3-year PFR proven trial, 2 adjuvants. These are the newest that we have. There's a few more that we've tested a few years back. Full Tech adjuvant is PFR proven, offered a return above and beyond the fungicide of $12.12 an acre. 82% of the time, it offered a profitability ratio and offered a yield advantage of 2.9 bushel per acre. Zion silicon gel, there below it, is a little bit less than half of the return, and a much lower ROI win percentage. I do want to be careful with adjuvants with a fungicide application, especially when that corn is just starting to shoot tassels out. NIS, crop oil, and MSO can burn ovules and developing kernels, causing arrested ears. My stance for a long time has been we're going to keep the adjuvants out, maybe put in a drift retardant, but I'm not going to use something that might be a spreader or a penetrating agent to get that product into the leaf faster. We want to kind of stay away from those. So from my standpoint, with the drone that I fly on trials, it is drift retardant only. Nothing else that I'm putting in the tank. We don't want to risk this. Fungicide timing. So that growth stage, we had some questions there on growth stage itself. This is a 4-year PFR proven study here, and it simply shows in corn, R1 provided the highest returns. Actually, all others except for V10 are not profitable at all. And if you add the application charge into that V10, it becomes negative very fast. ROI win percentage at the R1 application is 69%. So this kind of wraps up several products that we've tested over time. And it was just the selection for that trial was the growth stage only. I also forgot to mention in the upper left-hand portion of my slides, we have the crop that I'm talking about. In case I don't mention what crop we're on, take a look up there. That, of course, in this slide is an ear of corn. Next up would be time of day. So in corn, spraying in the morning versus that untreated control there on the left-hand side offered us $21 an acre. Whereas spraying at 3 p.m. in the afternoon when our temperature and maybe humidity might be a little bit lower, temperature's higher, our returns come back down and we only made $11 an acre. You add the application charge into that, we might be just at break even. So I like to spray till about noon, 1 o'clock and stop. That's a good way to do it if you can get your acres covered. Now, if we're full-blown disease, we're going to cover as much as we can in the morning. If we have to spray some in the afternoon to achieve that targeted growth stage, we might just have to do that. Carrier rate comes into play here as well with the ground machine. So our control is no fungicide. Then we've got 10 gallons, 15, and 20. Not a lot of difference between the 15 and 20, but if you compare that back to the 10 gallon per acre carrier rate, there's a substantial increase in return on investment. This trial was sprayed many different times throughout the day, throughout the years that we tested it. We did not select just a spray in the morning. It was set up, the protocol, just to spray when you could get that application made on the research farm. Now, would I recommend 20 gallon per acre in corn versus 15s? Your efficiency and logistics become much tougher and much slower to carry that much product and then tend that much product to get your job done. I'm going to recommend 15 gallon per acre if I could spray in the morning and get it done. Now, planting date. So early planting dates on the left with a fungicide application. There in April, $20 an acre return. May 1st through the 15th offered $23, and then May 16th to 30th, we're getting a lower or a later planting date window there. But you can see our return on investments did increase. So my main point here is going to be don't give up on your later planted crops, especially in the presence of disease. That goes the same here with thin stands. So we've got in our boxes there 32,000 plants per acre normal stand, normal spacing, our untreated controls on the left, and then Trivapros on the right. As we move right along this graph here, you can see our stands went from normal spacing to sporadic spacing, and then our populations decreased. Our returns diminished a little bit, especially when we get down to 20,000 plants per acre. However, our return on investment is still positive. So don't give up on your lower stand fields as well, especially in the presence of disease. We're still going to pull that trigger and take care of our crop. Next up, we're going to move into soybeans here, talking about PFR proven. The products there, just like that first slide in corn, Maravis Top, $48 an acre return on investment, a very good ROI win percentage of 86%, yield advantage of 6.5 bushels, 100% of the time is offering a yield gain, and then of course our timings, modes of action, and the company that provides those products there on the far right. And then adjuvants, again, a lot more that we have here on this slide compared to corn. The watch-outs aren't quite as high as they are in soybeans as they are with corn. Full Tech, again, leading the charge on top on this slide. $20 an acre return on investment and a win percentage ratio of 69%. Yield yield gain win percentage is 75% with Full Tech. All the other adjuvants on the screen were profitable and had good win percentages and yield win percentages. Now, we didn't talk about nozzles on corn, but we do have PFR nozzles for the fungicide trials in soybeans. The Greenleaf Turbo Dual Fan offered the highest return, and the XRs offered $8 less, and then the Twin Jets was just above break even. It would be T-Jet Twin Jets. In corn, the data, we've got a 1-year trial so far in corn. The data is a little bit different with it. The Twin Jet induction nozzles offered a good return while the XRs was much lower. So in soybeans with the green leaves, that droplet spectrum is coarse, medium, and fine, where an XR, depending on the size of the nozzle tip that you have, is typically going to provide much finer droplets. So in corn, we got to try to drive that solution, that droplet spectrum, down to at least the ear leaf. In soybeans, we're trying to protect the upper portion of that plant. Same with corn. Time of day is also important in soybeans. 8 a.m., $12 an acre return versus the untreated control, and then 3 p.m. Just like corn, when I spray beans on my farm, I start up as soon as I can drag myself out of bed if dew is on the plant, and I'm going to shut it down at noon, 1 o'clock, and then start again the next day, especially when it comes to carrier rates. Because in beans, as we increase our carrier rates up to 20 gallon per acre, our ROI is much higher. So logistics do become tough here, but if you go from a $10 return with that 15 gallon application and go up to an $18 return, that's worth the added strain on your efficiency to do that. So I'm going to choose to go ahead and spray at 20 gallon per acre, spray from 6, 7 a.m. till noon, and then we'll start again the next day. Same as corn here. Don't give up on your later planted soybeans. The returns are much higher here if I had to pick one crop or the other. We're going to pick one planting date or the other. We're going to pick our later planted beans than the early planted beans as far as the fungicide application goes, based off return on investment. Last up with beans is similar to corn, a population by fungicide response. 100,000 plants per acre is on the left and 150 is on the right. So our lower seeding rate did offer higher returns than our higher seeding rate. So we're going to focus kind of on that as well, just like the planting date. Now, when it comes to application methods, there's about 4 ways we can do it today. Number 1 is your conventional ground machine. 2 would be airplane or helicopter, and then the drone. We're going to start with the ground machine and the drone, a 2-year study at the PFR locations. So at Beck's, we have 9 owned Beck or PFR locations, and all protocols and trials are done the same exact way from site to site. So this trial here comes from 5 locations in the last 2 years. The ground machines on the left compared to an untreated control. $4.84 return on investment. The drone for the past 2 years has offered a $10 higher return on investment at $14.75. We'll talk about kind of why we think that might be here in a few slides. Moving to soybeans next, the same exact trial. The ground machine at 20 gallons per acre. We actually lost money over the past 2 years, and that's kind of an anomaly in soybeans. Usually we see a spray application of fungicide at R3 in beans to be profitable, but the past 2 years, it hasn't been near as profitable as previous. The drone, on the other hand, was profitable at $13.78 an acre. Next up would be carrier rate with the drones. We've talked about carrier rate with the ground machine. What about the drone and corn? My control being no fungicide, and then 2 gallons per acre, 2.5, and 3 with 7 ounces of Valtima. At the 2 gallon per acre rate, we gained almost 4 bushels to the acre, 2.5, 5.3, and then 3 gallon per acre was a 6 bushel increase. If you look at the return on investments, we didn't quite have enough bushels to break even except for the 6 or the 3 gallon per acre rate. Here's the point I want to make with this. If you have a drone operator that is trying to get you to apply fungicide at 1 gallon per acre, number one, that is off label. There is no aerial application applied fungicides that are labeled at a 1 gallon per acre rate. The only reason why drone companies or applicators are trying to do that is to gain efficiency in the field. I'm going to stick with 2 as my base. If I've got the time or the drone that has a fairly large tank on it that I can afford to spray higher rates, I might bump up to 2.5 to 3 gallon per acre to see if I can increase my yield gains or profitability. We'll move on to soybeans here. Similar data. You look at the yield trend, this is with 8 ounces of Revitec. Our yield trend does go up with the carrier rate volume. However, none of those applications last year were profitable. Next up is a big project that I've had a large part of the past 3 or 4 seasons. It's fungicide application, ground versus drone versus aerial trials. These are on-farm trials, so big fields. Some of these fields could be upwards of 200 acres. They are replicated just like any other trial that we do at a PFR site. So kind of how I set those up is I will do a strip of a ground machine, airplane, an untreated control, and then the drone. And then I would replicate that 3, 4, 5, or 6 times across the field, however big that field will allow. And then we will analyze the data at the end of the season. Here's what we saw in 2024. When we bring in an airplane here, so we'll save the helicopter for later, my control at the top is no fungicide. Then our applications was a ground machine at 15 to 20 gallons per acre, depending on the cooperator I was working with. The plane was 2 gallons per acre, and the drone was 2 gallons per acre. None of these treatments had adjuvants in them, minus a drift reducer for either the plane or the drone. You see the yield trend there on the far right. They all had yield gains. That data was very tight last year, but profitability-wise was actually negative, and that's without the application charges. Last year, all these trials, I never really seen heavy disease levels in any of these trials, and we're going to dive into individual fields. So Stanford, Illinois, that trial would be just south of Bloomington. All those treatments were negative as far as profitability goes. Kilburn, Illinois, that would be south of Havana, Illinois. The plane was just above break even, but the drone made $29 an acre in that irrigated field. You can see disease pressure for both of these. For the Stanford was light southern rust and moderate tar spot, and for Kilburn was light tar spot. We go to field 4 in Marietta, Illinois. That's in between Peoria and Macomb. Everything was negative there. However, the plane did get pretty close to that break-even line. Lastly is Canton, Missouri. The only profitable application was the ground machine in Canton, Missouri. Now you can see, if we were to back up a slide, we look at these again, the variability between applications is certainly there from field to field standpoint. If I bring 2-year data together, if we look at 23 and 24, the ground machine was just above break even. The plane was negative 408, and the drone showed positive at 613. You add application charges in for the past 2 years, we're going to be below break even. If I was to remove one field from 2023, that data set for the airplane would actually be the same as the ground machine. So from an application standpoint in corn, everything's actually pretty close.
And while we're here, I had a couple questions come in the chat box. So 2 questions when it relates to drone applications. Are the drone spray tests sprayed with dew on the leaf surface? And a follow-up question is, was the pH of the water consistent between ground, plane, and drone applications?
Okay. So the first question there was dew present when the applications were made. How I line these up is basically my airplane, getting the airplane in is the kingpin. So when the airplane can get to the field, I line up the ground machine and the drone, and we all try to spray right after another. So some of them will have dew present, a lot of them don't, depends on when the plane can get there. That's going to be various across all those trials. The pH question, the water source that we use for the 3 applications that are in these trials is all the same water source. I test the pH of those. I've got records of everything, but it's all the same exact water source.
So you would say, if you were doing a trial, all the applications, ground, drone, fixed wing, or helicopter, they all are containing the same leaf surface wetness, right? From a dew standpoint, because you get the aerial applicator come in and you do the other 2 right when they finish up. And then all water sources for each individual location are consistent. They're all the same, correct?
That is correct.
One more question on these trials. Are specific hybrids chosen for the PFR fungicide testing? For example, are you using hybrids with higher fungicide response ratings?
Usually, the trials that are at the PFR sites are split hybrid, especially for the timing trials and product trials. So there might be one that is susceptible to a fungicide application and one that isn't. For the on-farm trials, no. We're going to run whatever hybrid and field that the cooperator chooses. So I'm not hybrid specific on those trials at all.
Awesome. And we got one more question. It's from Ben H. I think I'll wait till the end and open that up. It's a technical question about selectivity of fungicides. So Ben, we got your question. We'll hit that as Clayton wraps up here towards the end.
Okay, very good. Now we'll transition from the airplane trials to the helicopter trials. Unfortunately, last year we happened to line up to where the helicopter trials, I had rain before each of those, and the ground machine couldn't get into 2 of my 4 trials. So we only ended up with 2 final locations last year because of that. And one of those 2 locations had heavy tar spot. So you see the yield increase here across the board, whether it's ground, helicopter, or drone, was much higher than the airplane trials. and the return on investment there in the far right column was largely a lot more profitable. If I split these fields up and go through each of them individually, we look at the field of Wapello, Iowa. It had moderate to heavy tar spot. The fungicide that was used in that trial was Moravis Neo. All applications here were profitable. A ground machine, $86 an acre, helicopter, $72, and then the drone, $118 an acre. I remember this day when we sprayed that last year. This was an irrigated sand. It was hot. We sprayed about noon. I didn't want to, but that's when the helicopter could get to us. It was hot, and we still seen good returns. This proves in the presence of disease, a fungicide application is going to preserve yield. Now, the other field in Teutopolis, Illinois, that's close to Effingham. Disease pressure was light, seen very little at all. Again, profitability is really slacked off when we did not have the presence of disease. You had the application charging for the drone there, it would be at break-even levels. We look at the 2-year graph here. More profitable than the airplanes, but that's just because of field variability and disease presence in those trials. All applications pretty profitable here and pretty tight data set. Moving into 2025 research. So every year we're coming up with new trials and then kind of pushing that needle every single growing season. New trials for 2025 is a fungicide versus sulfur study, seeing if we can increase that plant health enough to help fight off disease without utilizing a fungicide. The control or the treatments for that trial would be there in the gray boxes. So my control, untreated, Moravis Neo at R1 and corn, thiosol 2x2x2, and again at V3, then a combination of the sulfur treatment and the Moravis Neo at R1. At the end of the day, we're trying to see which is the most profitable. Fungicide timing and product study. So V5 versus R1. This is a combination trial of Trivapro, generic azoxystrobin, and then Quilt XL. You can see the combinations though. I'm really excited about this trial, bringing a generic into our testing, especially in lower grain market times, to see if we can increase those yields a little bit at a lower cost. Fungicide replacement study in the lower right there. Of course, we have a fungicide there, but then 3 other products that are not a fungicide to see if we can get a benefit out of those. And then lastly, the adjuvant study. So we're going to bring some of those adjuvants in the drone testing here in 2025 to see if we can get the same effect out of those with a drone versus a ground machine. Now, what are some of our theories behind the effectiveness of an aerial application versus a ground application? When I started these trials 3 or 4 years ago, when I analyzed the first set and the airplane had a higher yield gain compared to a ground machine, I about fell out of my office chair. I always thought the ground machine would be far superior, but that year the plane was well ahead. And here are some reasons why we think that. pH, I'm going to talk about that one in depth here in a second. Canopy movement, so that's either the airplane moving the canopy, the props on a helicopter or a drone, moving that canopy, allowing that solution to get deeper into the canopy. Wheel traffic with the ground machine, does it have an effect where your wheel stands, your wheel motors are? Of course, a lot of that is ear height. Is that changing yield at all? Droplet spectrum, they're going to be different for all applications. So a drone does not equal an airplane or helicopter, the same with a ground machine. Then lastly, canopy penetration. Can I drive that solution deeper with a drone or a helicopter or airplane versus the ground machine? We'll talk about pH here specifically. This is product half-life by pH for herbicides, fungicides, and insecticide. I'm going to talk about fungicides specifically. The moment you mix your solution, that starts the timer for the half-life of that product. So a pH of 9 for fungicide is 2 minutes. Can I mix and spray in 2 minutes? Largely that answer is going to be no. When my pH of 9 drops to 7, it's 3 hours. So if we can get our pH down to 7, or if I started at 7, we're going to be in a lot better shape. pH of 5 is 10 hours. So if I get that pH more acidic, our time that our solution is in good shape and is going to be able to be taken up by the plant is going to be much better at lower pHs. Where does a drone or an aerial application fit into this? So imagine that you've got two containers. You've got a 2-gallon container and you've got a 20-gallon per acre. My example here is 13.7 ounces of Moravis Neo per acre. So that's the acre rate with Moravis. So if I take my water and I fill my container up to where there's only 13.7 ounces left in that container, then I drop my fungicide in and fill that container the rest of the way up. My starting pH with water on this test was 7.9. The moment I mixed in my Moravis Neo, my pH dropped from 7.9 to 6.4. That's a 19% reduction in pH. Now that 20-gallon per acre container, water in that specific container started at a pH of 7.7. When I dropped in my 13.7 ounces of Moravis, it dropped to 7.08. That's only a 9% reduction. So I reduced the pH with the drone application or the aerial application 10% further than I did with the ground machine application. This is going to vary greatly by fungicides and the rate. So Veltima, for example, starts at a little bit higher pH and is only 7 ounces per acre. So we cannot buffer that pH down quite as far with Veltima when we compare it to Moravis. My main point here, when I ask growers at a meeting, how many of you know your spray water pH? And I ask them to raise their hands. You'll get 1 or 2 out of a 50-person crowd. So I challenge you to get some pH test strips or even just a pull float you can buy from Walmart and just test your pH and kind of have an idea of where you sit. The water that I pull from my well at my farm is 8. So I like to buffer my pH down. There's plenty of products that can do that. Full Tech Adjuvant, I believe Full Tech Cube. Brandt Indicate 5 is a good one because it actually turns colors. When your pH hits 5, it turns pink. So then I can load it, I can spray and go. So those are some products that I like to use to buffer my pH. Kind of the last topic here. Should you own a drone for your operation? So you as a farmer, would you purchase or would like to purchase a drone for your operation? I'm kind of in that pool of people that have thought about this, especially flying one for research. Just from an efficiency standpoint, here's some numbers putting the math into it. So a drone, typically your average, your acres per fill is going to be 5 acres per fill up. Acres per hour, you're probably going to hover around 30. Most newest drones can achieve that number. And then hours to spray. They're going to be 33 hours to spray 1,000 acres. Ground rig, 80 acres per fill. Acres per hour is 85. And then 12 hours to spray that 1,000 acres. So if you look at these numbers here, not taking the cost into this, ground machine's a lot more efficient. You bring the cost in, maybe you've got a standard height sprayer today. To invest in a high clearance sprayer might be a much higher expenditure than a drone itself. When we bring the drone numbers into this, so a DJI T40, probably the most popular drone out there today, it's made in China, 10.5 gallon per acre capacity, swath width, roughly 32 foot. This is their marketing material, 30 to 40 acres per hour. We're looking at $35,000 with the drone, charger, batteries, dry hopper, and generator. Helio Aries 150. That is a drone that is assembled and built in Texas. 13-gallon tank, up to a 40-foot swath. Again, that is their marketing material, up to 70 acres per hour. A little bit more expensive here, $58,000 to get that drone with the charger and batteries. On this one, the generator, you're on your own. Remember, I said the swath width is the marketing material. So last week, I am flying that Helio Aries 150 We did pattern test it in Mattoon, Illinois at a pattern fly-in day. I was the only drone there. So we had 7 or 8 airplanes, 1 helicopter. They string out a string about 75 feet, 80 feet, depending on the width of the airplane or helicopter flying. For me, we're not flying near that swath width. We fly across that string, we fly with dye, and it's going to land on that string, and they're going to read that through a device, and it can see our pattern. This is my first flight. If you look on that screen, blue is past 1, orange is past 2, and then green is past 3. I'm sorry, I said that was my first flight. It was my second flight. And you can see my location, center location being 0. All 3 patterns were different. And that was at a 15-foot altitude, 30 miles an hour, and the atomizer set at 30%. We cannot contain that pattern with water only. If I look in that box on the right, my volume median diameter is 265 microns. Labeled microns for fungicide is going to be roughly at 300. My droplets were way too fine. So we made some adjustments here. We dropped my altitude from 15 feet and we set my atomizers at 24%. My location being 0 here, the wind did change direction. I had quite a crosswind, but you can see past 1, 2, 3 was almost identical. The average patterns of all those is there in the blue at the bottom, and we landed on a 26-foot swath. Helio's marketing material says 40. I'm going to run 26. If we're going to run their wide swath, we're going to streak fields, especially in the presence of disease. Or if we're spraying herbicide with the drone, same thing. So I do highly recommend pattern testing your drones. There is a way today that you can do it by yourself through an app called Drop Flight. You can buy spray cards and that app will analyze those spray cards. When I reduced my atomizers from 30% down to 24, my microns got much healthier at 335 at a size that is better with a fungicide application. That also helps me contain my pattern. Factors to consider. So if you're new to drones and you're thinking about buying them, there are a ton of things to think about. Number 1 for me would be pattern. Number 2 would be crashes. I crashed 4 times last year. I guarantee you it's going to happen. Matt and I sprayed 4 trials last Friday. Good shape. We got everything done. We never crashed. But these are some things you've got to think about if you're going to walk into this. Next up, you got to remember you've got to have a trailer or some way, a deck to fly off of, brand and size of drone, software training, licensing needs. You're going to have part 107 and part 137. Ground crew, I never fly by myself. I always have somebody else with me. Chemical storage and mixing setup. Number of batteries. That is crucial, especially the size of your generator. Make sure your generator can charge the batteries you have quickly. The generator I had last year, it took an hour to charge batteries. This year it's 10 minutes. So we're much more efficient coming into 25 than I was in 24. Top reasons I would consider owning a drone as a farmer. Growth stage timing we talked about, whether it's corn or beans, R1 in corn and R3 in soybeans, and then the environment. If I call a spray service, whether it's an airplane, helicopter, or ground machine, when will they get to the field? This growth stage of application is critical. There might not be time to wait. So if I make that phone call to anybody, if it's a week from the time I call, we might be in R2, R3 territory. And you've seen by our data sets, our returns drop off very quickly. Flexibility, rain delays with the ground machine. I can get in with the drone, and so can an airplane or a helicopter. Flexibility to choose what time of day I spray. So if I've got a drone, I can make that decision myself. Same with the ground machine. And then what day to spray as far as making that phone call. Low cost of ownership and the potential for added income. Drone, it's got a pretty low cost of ownership as long as you can keep it in the sky and not crash it. And then added income for your operation. To summarize everything we talked about, Spray in the morning when the humidity is high and temperature is low if possible. Carrier rate for a ground machine application should be at least 15 gallon per acre. Pay attention to pH for longer droplet survivability. Don't give up on reduced stands and later planting dates. If your application method has worked with you, stick with it. Today, I don't know which one I was to pick if I was going to start fresh farming. I think they all have their benefits. And then pattern test your drone if possible. You could also ask your airplane service or helicopter service if they've pattern tested their machines. That is a voluntary procedure. It is not required. A lot of the good services do pattern test each machine on a yearly basis. That wraps up my part of the presentation. We do have CCA signups if you would like to get CEUs for attending this meeting today. You can scan that QR code. No need to sign if you scan it. John, we'll roll back to the questions you've got.
All right. Thanks, Clayton. Pertinent to the aerial application, have you ever or could you harvest weigh 2 to 4 rows at a time across the pass on an airplane, helicopter, drone, and ground rig to check effect of spray pattern, wheel damage, etc.? Maybe to help understand a little bit of the differences in the application method data.
The hard part about doing that in the on-farm trials, the answer is yes. Could I? Yes. The hard part is I haven't had a trial that has been side by side of just plain control. I've always got some sort of application right beside it, and I only take centers of those applications for data. A good pattern tested machine shouldn't have any changes from one side of the trial or treatment to the other. Before we get too complicated here, the other part of this is planter size, combine size, and width of application really change how my trials are set up. So for example, a 30-foot head and a 90-foot swath width for an airplane or the ground machine makes it to where I'm only harvesting 30 foot on the outsides and 30 foot in the middle. So I haven't been able to get it done with a research combine, but it has been a goal of mine to achieve that, if that answers the question.
Yeah, I think it does. I want to open this next question up to Mike, Matt, and Clayton all at once. This goes back to fungicide efficacy, but do fungicides reduce the bad fungi or pathogens like tar spot, gray leaf spot, and the helpful fungi like soil biology? Could that mean that an unneeded application of fungicides could be detrimental to soil health? Mike, I see you perk up there. Why don't you take that first?
Yes, and all those things. By all means, can't say I've searched recently some of the academic research, but by all means, the other thing we got to keep in mind, if there's beneficial fungi in the environment, we're trying to be judicious, whether it was Matt's conversation, mine, or Clayton's. That's where I come back to every field, every farm. And then the other thing we got to keep in mind, if we're putting the fungicide, aerially, foliar, if you will, on an actively growing crop, there's academic data that shows that in the soil not being beneficial, but the odds of us getting that fungicide in an active state, going back to Matt's component, if even our best fungicides, if we have a 10 to 14 day window on the plant, and we're hoping we have plant uptake, to keep it simple, those products in general very rarely make it to the ground where we're trying to, in this case, mycorrhiza fungi and some of the others. That would be my experience and thoughts. Matt can add, or Clayton can as well.
Yeah, the thing I would add, Mike, I think the way you kind of wrap that up at the end makes a lot of sense. I would say also think about it above soil, because just from some past experience, I do think if you get too aggressive with fungicide use, like maybe droughty environments, I've seen some things in the past where I'm pretty sure we knocked out enema pathogenic fungi, things that actually knock down insects and insect relatives, and have seen some pest resurgence in those cases. I can think of actually just again past experience, things I've observed, some spider mites popping up in corn after I saw some late fungicide applications, and I think that just again speaks to what Mike's talking about. We got to remember that we want to use these tools wisely, and we want to pay attention to the environment that we're going into. In some of those past experiences, it was a really dry environment, and when you combine that with knocking out some of those enema pathogens, we had these spider mite spikes that were kind of unusual. So,
Yep. Excellent point.
Clayton, hot seat question. Money's not an option. Ground rig, spray plane, drone.
Is that buying one or calling one in?
Which one are you having on your farm to apply your fungicide?
On my farm, I'm going to do a drone. On my farm. And that's because I've got not square fields. And with the ground machine, we're really gonna trample some in rows. Airplane's not gonna be able to spray a lot of our fields and farms. A drone for me fits in, and I can pull the trigger on when, how, and what time of day to spray. So for me, it's a drone. Cost of ownership. I know these costs out of it, but yeah, I'm gonna pick drone because I can be in control. Now,
that's a great point you make right there, because I think time of day, growth stage of crop, your product mix, what you want to put in it, really are big driving factors in the whole fungicide decision. So I think ability to be in control and control your timing outweigh the actual mechanical aspects of any of them. So.
with the ground machine, I mean, if it rains, you're out. You got corn that's 10, 12 foot high and you've got 3 inches of rain, you might not be able to get in. So drones, ultimate flexibility for me. Of course, you can always rely on the aerial service as well.
All right, guys, we are dried up on questions from the text line and from the chat box. To all the people that joined us today, I want to thank you for taking time to join in on this. The information was good, very helpful. And to all the participants on the call, these guys are available. Matt, Mike, Clayton, even if they're not in your direct area and you got questions or want to learn more, reach out to them. They'll give you their insights. They'll connect you with somebody from a local place that one of our field agronomists or PFR team locally that can really help dive into those fungicide recommendations. And check out our agronomy documents on the website, everything from the PFR data to the sheets that Mike shared with us today. They're available on our website if you want more resources to help you out with those fungicide decisions. So again, thank you everybody for joining the call today. Never hesitate to reach out to anybody on our team to help you through these fungicide decisions. Have a great day, everybody.
Awesome. Thanks, everybody. Thanks, John.